This is a sum of cubes. And we've talked about the difference of cubes, which is where we have a difference where you're actually having subtraction. But now we have a sum of cubes because this is when we're adding two values that are cubed together. So let's do a couple of examples. Here, first of all, is our formula. Here's our template. When you have a sum of cubes, it's base 1 and base 2. This is the two values being cubed. So we have x plus c. You add the two bases. Then you have x squared, which is the first base squared. C times x, which is your two bases multiplied, the product. And c squared, which is your second base squared. Now, if you notice, this is identical to difference of cubes, except for this one, this sign, and this sign are switched. It's the same format, the squaring, the product, the squaring, and the two bases, except for the signs are switched around. So let's do our first example of sum of cubes. So I'll do x cubed plus 27. Now remember, when we do this, we want to see, is this a sum of two cubic values? And in order for us to determine if this is a sum of two cubic values, we have to determine, are these two perfect cubes? Well, this one is a perfect cube. So we've got x cubed and 27. The x cubed is already cubed. We know that's a perfect cube. So we need to see if the 27 is a perfect cube. And it actually is. I can actually write this as x cubed, and I always put parentheses, plus 3 cubed, because 27 is a cube. It's a perfect cube. Now that I have this, all I need to do is plug into my template using my two bases. And remember, I always write out the formula or template, whatever you want to call it, with my signs and fill in what I need to. So let's look at, first of all, let's identify our two bases. Our two bases are x and 3. So if we follow the format, x and 3 go in the first two spaces. The second part, x squared, that is our first base squared. Our first base is x. So when I square that, I get x squared. The last one is our second base squared. So that would be 3 squared, which is 9. And our center term is the product of our two bases, which is x times 3, which is 3x. And we are done. So that is a simple example of a sum of cubes. So let's do another example. So let's say I have 8y cubed plus 27. And we'll do x cubed. I want to do the same thing and identify what I'm exactly cubing here, what my two bases are. If I look at 8, 8 can actually be written as 2 cubed. So this is 2 cubed, y cubed. That is a perfect cube. 27 is also a perfect cube, so I can write that as 3 cubed, x cubed. We know that from the previous example. Now remember, we like to have it in this format where your bases are all together. Since both of these are cubed and they're multiplied, I can rewrite it like this. This is the same thing as 2y cubed, the quantity, and this is the same thing as 3x cubed. Now I'm ready to put it into my formula for my sum of cubes. So I'm going to put my two factors here, my plus, minus, plus, and now I'm going to look at my two bases. My two bases are 2y and 3x. So we have 2y and we have 3x. The two bases are 2y and 3x, so I'm going to have 2y and 3x, holding true to our formula. Then this term here is the first base squared. Now that's 2y squared. When I take 2y and I square it, that becomes 4y squared. So this one's going to be 4y squared. This one is going to be my second base squared, which is 3x. So I have 3x squared, which is 9x squared. So that's what goes here. And the center term is the product of the two bases. So I've got 2y times 3x, which gives me 6xy. And that is the basic formula and process for doing a sum of cubes.